We have two equations of two variables x and y with exponential expressions. For such equations, a standard approach would be taking logarithms on both sides. But before that, let's look at a clever method. Squaring both sides of the first equation, we have x to the power 2xy equals y to the power 8. You will see right away why we do this. The left-hand side becomes x squared to the power xy. This is the basic rule for exponent calculation. We multiply this equation with the second equation. Both left-hand side of the two equations have the same exponent, xy, with different bases, x squared and y. So we got x squared y to the power xy equals x to the power 16 times y to the power 8. Therefore, x squared y to the power xy equals x squared y to the power 8. Compare the left side with the right side. They have the same base. How can this equality hold? There are two cases. First, they have the same exponent, mean xy equals 8. The second case, the base is 1, x squared times y equals 1. Case 1, xy equals 8. From the first equation, x to the power xy equals y to the power 4, we replace the exponent xy with 8. We have x to the power 8 equals y to the power 4. We are looking for positive solutions only, so we have y equals x squared. We substituted in xy equals 8. We have x times y, which is x squared. So we got x cubed equals 8. Therefore, x equals 2 and y is x squared, which is 4. Case 2, the base x squared y equals 1. Again, we look at the first equation, x to the power xy equals y to the power 4. We multiply the equation on both sides with x to the power 8. We have x to the power 8 times x to the power xy equals x to the power 8 times y to the power 4. The right-hand side can be simplified as x squared y to the power 4, which is 1. Therefore, x to the power 8 times x to the power xy, which is left-hand side, equals 1. So we have x to the power x plus xy equals 1. We are looking for positive solution. So 8 plus xy is positive. So the only possibility is that the base x equals 1. Therefore, y is also 1. The second approach. In general, taking logarithms is useful when we deal with exponential equations. Let's try it. We take logarithm. The first equation becomes xy times log of x equals 4 times log of y. We are using natural log. The second equation becomes xy times log of y equals 16 times log of x. Then we multiply the two new equations, left side with left side, right side with right side. The left side is xy squared times log of x times log of y equals the right side. 4 times 16 is 64 times log of x times log of y. Rearrangement, it becomes xy squared minus 64 times log of x times log of y equals 0. The multiplication of three factors equals 0. Let each of them equal 0, we solve for positive solutions. So similar to the previous case, I skipped the details and we got exactly the same solutions. A couple of comments. First, the system of equation indeed has a pair of negative solutions, x equals -2, y equals -4. However, for exponential equations, we only discuss positive solutions. In theory, exponential function f of t equals a to the power t, we always assume it has a positive base a. Otherwise, it won't be well defined for real value t. Secondly, is x equals y equals 0 a solution? Both sides equal 0? The answer is no. As a matter of fact, 0 to the power 0 is undefined. In other words, it can be anything. This is one of top secrets in calculus. Thank you for watching. Please consider subscription of my channel. I appreciate your support.